Now we're going to get into the purpose of the RUV that we created in the last video. So RUV is equal to XUV, YUV, ZUV with parameter domain D be a smooth parameterization of surface S. Furthermore, assume that S is traced out only once as UV varies over D. The surface area of S is this double integral TU cross TV, the magnitude of that dA, where TU is dx du, dy du, dz du as a vector, and TV is dx dv, dy dv, and dz dv. And what I want you to see below here is this picture. So what I want you to see here is when I calculate TU and TV, these are vectors from a point that I choose. And when I think of those vectors outward, when I take the magnitude of the cross product of those two vectors, that's going to give me the area of this parallelogram. Now what that means is, if I think about doing that for every point, I'm going to get all of these areas. Now, when I set it up as an integral, the integral is actually going to squeeze all of those areas down to a point, so then I can get a precise surface area, because the double integral is really just the limit as n goes to infinity, which means these are going to squeeze all the way down to 0 in a sense. So that's what's going to give me this surface area, and we're going to use this TU and TV to figure that out. So we're going to take one of our previous problems just to get an idea of how this equation actually works, this formula here. And then we can see this actually in action. So here we go. This problem says find the surface area of the paraboloid z equals x squared plus y squared for z between 0 and 9. So again, remember, I'm just going to pick a u and a v here. So anytime I see anything that looks like x squared plus y squared and then a linear z, or what other things, cylinders, I'm thinking of cylindrical coordinates. So that's going to be my transformation I use here. So then I'm going to say my u, well, let me go there first. So my x is r cos theta, my y is r sine theta, and my z is z. So when and don't forget my x squared plus y squared equals r squared, and tan of theta equals y over x. Okay, so what I'm looking at here then is my u is going to equal theta, and my v is going to equal r. And then when I think of my RUV here, that's going to be v cos, I was going to write theta, but u, and then v sine u. And then for the last component there, my z component over here, what I'm going to do is I'm going to take this equation here, since it's the z is the dependent variable and the x and y are my independent variables. And I do know x equals v equals theta, and v equals v times sine theta equals y. So what I'm going to do here is I'm going to actually use this other equation, x squared plus y squared equals r squared. So I'm going to say z equals r squared. And remember, v equals z, so this is really v squared. So really z equals v squared, and I'm just going through the same process I did in the last video. So that means my parameters here, my z being between 0 and 9, now it's going to be v squared is between 0 and 9. And when I square root both sides, my v is going to be between 0 and 3. And I also now have my z equaling v squared. So there's my RUV, and there's my parameters for my v. And what are the parameters for my u? We'll talk about that in a minute. Actually, yeah, we'll talk about it in a minute. Okay, so anyways, so let's take a look at now, what is this TU cross TV business? Because what we're looking at here for this surface integral is this TU cross TV. So really this TU is just my RU. It's the derivative of my RUV with respect to U. So that means my first component then is going to be negative V sine U. And my second one is going to be V cos U. And my third one is going to be 0. Because keep in mind, it's with respect to U, so V squared is just a constant, so it's 0. Now I'm going to do RV, and notice I'm writing them over the top of each other. And the reason why is because then I can take the cross product pretty easy without rewriting it again. So then for this one here, now I'm going to do the RV. So that's going to be cosine U, comma, and that's with V as well. So that's going to be sine U, comma, and then the last one's going to be 2V. So now I want to think of I, J, K here, and I am thinking of cross product. That's going to result in, let's see here, 2V squared cosine U, and I'm thinking about these being covered up, and then I do this product minus that product, and the second product's going to be 0. So I'm just going to end up with this as my component for my I. Okay, now I'm going to do my J here. So now I'm looking at 2V times negative V sine U. That's a sine U. I should fix that. Okay, so that's a, and don't forget to negate it at first too. So I'll do that first. So negative 2V squared sine U, because I'm timesing those now. And then minus timesing those, which is 0 again. So that's what I end up with. Now for the last one, the K here. So that means I'm going to get negative V sine U squared, or sine squared U. And then it's going to be minus those two there. So that's going to be minus V cosine squared U, and that's the third component. Now we can definitely clean this up, and we should. If we don't, we can lose points for this. So 2V squared cosine U, comma, and those negated each other. So I'm just going to have 2V squared sine U, comma. And if you notice here, if I can pull a negative V out of both of those, I'm going to get sine squared U plus cosine squared U. And that's going to be 1. So I'm just going to get a negative V on the end. So that's my RU cross RV. Now keep in mind here, it has to be the magnitude of that. That TU cross TV is really RU cross RV, to be specific. So now we're just going to take the magnitude of this. So and the magnitude is just taking the square root and squaring everything. So that's going to be 4V to the 4th cosine squared U plus 4V to the 4th sine squared U plus V squared. And we can definitely clean this up some. If I pull a 4V squared out from both of those, I'm going to get that cosine squared plus sine squared again, which is nice. So this actually does simplify to the square root of 4V squared, or excuse me, 4V to the 4th, and then plus V squared. Excuse me. And I can simplify this because both of these have a V squared in them. I can pull that out and square root it. So I'm going to get a V square root of 4V squared plus 1. So that's what I'm going to integrate now. So I'm going to put that in here. And then my bounds for both U and V. And then I'll have my integral set up. I think I'm going to finish this on the next page. Oops, I should take this last piece down. All right, so now I have the double integral. Give myself a little room so I can put my bounds in there, just a little bit. And then I have the 4 square root. Oops, it's not a 4. I'm sorry, it's a v. Square root 4v squared plus 1. And then I'm going to do du dv. So I know my parameters for my v here. It was between 0 and 3, so I'll put that there. And remember what our components equal to as well. Very important. One of these is supposed to be an r, so I believe it's this one. Okay, so that's my v equals r and my u equals theta. So don't forget about those components there. And then remember my v goes from 0 to 3. Okay, let's go back. So the easy one is from 0 to 3, that's my v. And then for my u, think about what u was. U was equal to theta. And keep this in mind, I'm going to be sweeping all the way around. So I have this paraboloid. I'll just show it to you. It's always good to have a nice visual for these. Here's my paraboloid. So with that theta is going to say, hey, I'm going to start here on the positive x. And then I'm going to take it all the way around. So that tells me right away then that my theta is going to be from 0 to 2 pi. So this is the actual integral we'll be integrating. And this answer will result in the surface area of the paraboloid for z from 0 to 9. So this integral is actually pretty nice. If I let I can't pick u now. Let me call it a. My a is going to equal 4v squared plus 1. I'm doing substitution. So then dA equals 8v dv. Actually, I don't need that right now. I'll do that next. Actually, taking a look back, I'm not going to do this yet because I'm with respect to u first. Almost got me. All right, so it's going to be from 0 to 3, and this is all a constant. Yes, it almost got me. All right, so this is just going to be v square root of 4v squared plus 1 u, and that u is going to go from 0 to 2 pi dv. And that equals when I plug in the 2 pi there, that's going to be the integral from 0 to 3. And I'm just going to pull the 2 pi out. No, I'm not. Well, yeah, I'm not pulling the 2 pi out. I mean, I'll pull the v square root of 4v squared plus 1 out. That's what I'll pull out. And then I'm going to have a 2 pi minus a 0 dv. All right, so then that's going to equal 2 pi v squared of 4v squared plus 1. So I'm going to pull the 2 pi out altogether and go from 0 to 3 here of v square root of 4v squared plus 1 dv. All right, so now what we're going to do is now we're going to do that u substitution I was talking about. And here I can use u now, but I'll use a. A equals 4v squared plus 1. So then dA is going to equal 8v dv. So I can move the 8 over to the other side. So I get dA over 8 equals v dv. And the reason why I'm doing that is because I have a v dv here. And now I can sub that in for dA over 8 for that. And then I can sub in for my u here. So this is going to be the integral, don't forget my 2 pi, from 0 to 3 of square root of of a. And this would be dA over 8. All right. So now the integral of the square root of a is really a to the 1/2. So a to the 3/2. Don't forget my 2 pi. A to the 3/2. And also don't forget my 8 here on the bottom. So I can just write it in over there. And this is an A. Let me fix that all, actually. It looks terrible. Over 8. A to the 3/2. That looks way better now. From 0 to 3. And hopefully you see here, this is just going to be pi 4. I'm going to write it that way. And then this A thing here is going to be 3 to the 3/2 minus 0 to the 3/2. And that's going to equal pi 4. And 3, and I should write it this way, actually. The square root of 3 cubed is really what we're dealing with in there. So that means I'm going to have 2 of them and the square root of 3 left. So I'm going to have a 3 pi 4 square root of 3. And this will be our final answer here. And like I said before, make sure you do simplify when you can. So this would be the answer for this one here. And just a quick recap, remember our formula we used here for this surface area. Here it is here. Don't forget about the formula. And the TU is just my RU, and the TV is just my RV, which is handy. Then I came over here and just did my magnitude and integrated with respect to the area for U and V. There it is.